Writing chemical equations. A chemical equation links together the substances which react, that is, reactants, with the new substances that are formed, that is, the products. Chemical equations are of two types: word equations and symbol equations. Let us learn about writing word equations. A word equation links together the names of the reactants with those of the products. For example, when a magnesium ribbon is burned in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write it in the form of a word equation. The word equation for the above reaction would be: magnesium plus oxygen reactants give magnesium oxide, which is a product. The substances magnesium and oxygen that undergo chemical change in this reaction are reactants. The new substance, magnesium oxide, formed during the reaction is the product. A word equation shows change of reactants to products through an arrow placed between them. Let us now learn about writing a symbol equation. A symbol equation is a concise representation of a chemical reaction in terms of symbols and formulae of the substances involved. In the word equation, symbols and formulae of the elements and compounds are written instead of their word names. An arrow means reacts to give. Sometimes an equal to sign appears in place of the arrow. Both are correct, so either of these can be used. At other times, a symbol containing two half arrows pointing in opposite directions may be used. This specifies the reaction is incomplete. Symbols and formulae of all reactants are written on the left-hand side of the arrow with a plus sign between them. Similarly, symbols and formulae of all the products are written on the right-hand side with a plus sign between them. The symbol delta placed above or below the arrow indicates that the reactants have to be heated in order to start the chemical reaction. The symbol G indicates that the substance is gaseous. Zn plus H2SO4 gives ZnSO4 plus H2 in gaseous form. The symbol L means liquid and S means solid. Abbreviations like DIL or CONC indicate the dilution or concentration of acids. An arrow after the formula of a substance pointing upwards indicates that the substance is in gaseous state and is coming out of the reaction vessel. An arrow pointing downward after the formulae of any product indicates that it is precipitated out and settles down, or that it is insoluble in that medium. The arrowhead points towards the products and shows the direction of the reaction. Let us have a look at few examples. Burning of magnesium in oxygen to form magnesium oxide as Mg plus O2 gives MgO. The symbol equation for reaction between zinc and hydrochloric acid is Zn plus HCl gives ZnCl2 plus H2. Acetic acid solution in water reacts with solid baking powder to give an aqueous solution of sodium acetate, water, and carbon dioxide gas. Its equation can be written as CH3COOH in aqueous state plus NaHCO3 in solid state gives CH3COONa in aqueous state plus CO2 in gaseous state and H2O in liquid state. A solution of sodium chloride when added to a solution of silver nitrate forms white silver chloride, which precipitates as an aqueous solution of sodium nitrate. NaCl in aqueous state reacts with AgNO3 in aqueous state to give AgCl in solid form and NaNO3 in aqueous form, where AgCl is a white precipitate. Nitrogen gas reacts with hydrogen to form ammonia and the yield is approximately 17%. N2 in gaseous state plus hydrogen in gaseous state gives 2NH3 in gaseous state. The reversibility sign shows that yield of ammonia is only limited, meaning that reaction does not get completed or is reversible. Types of chemical equations. Equations can be of two types: unbalanced and balanced chemical equations. Skeletal equations. A chemical equation that shows only the symbols and formulae of reactants and products is called a skeletal chemical equation. In an unbalanced chemical equation, the number of atoms of different elements on both sides of the equation is not equal. Mg plus O2 gives MgO. In this equation, the number of magnesium atoms on both the sides of the equation is same, that is 1. But the number of oxygen atoms is not equal. This means that this equation is unbalanced because the mass is not the same on both sides of the equation. In a balanced chemical equation, the number of atoms on both sides of the equation is always equal. The balanced equation for the burning of magnesium ribbon in oxygen is written as 2Mg plus O2 gives 2MgO, which is a balanced chemical equation. As a general rule, coefficients are always whole numbers. The atoms of one element do not change into atoms of another element. They neither disappear from the reaction nor do they appear somewhere else. It simply involves an exchange of partners during the reaction. No change in mass occurs and law of conservation of mass is applicable. Hydrogen plus oxygen gives water. This holds good in case of a water molecule. So this equation must be balanced. Each molecule of water contains one atom of oxygen and two atoms of hydrogen. This means that one molecule of oxygen, which contains two atoms of oxygen, will combine with 2 molecules of hydrogen to form 2 molecules of water. 2H2 plus O2 gives 2H2O. This represents a balanced chemical equation. Let us understand the meaning of coefficient. Coefficient. The coefficient is a whole number and is always written before the formula of the substance. It may mean the number of molecules, number of atoms or ions, number of formula units, and number of moles. The coefficient 2 in KClO3 means 2K plus 2Cl plus 2O3. This means that 2KClO3 has 2 atoms of potassium, 2 atoms of chlorine, and 6 atoms of oxygen. Let us perform an activity to understand the process in a better way. Materials required for the experiment are copper carbonate powder, lime water, concentrated hydrochloric acid, concentrated ammonia solution, lead nitrate solution, and potassium iodide solution. Half a spatula of copper carbonate powder is placed into a test tube. The apparatus is set up as shown in animation. Copper carbonate is heated and the gas produced is passed through lime water. The changes to copper carbonate and lime water are observed. When the reaction is completed, the delivery tube is withdrawn from the lime water and the Bunsen burner is removed. We observe that copper carbonate changes color from green to black. This means that copper carbonate decomposes into copper oxide, which is black in color. Carbon dioxide is released, which turns lime water milky. Let us write the word equation for it. When copper carbonate is heated, it decomposes into copper oxide and carbon dioxide. The presence of carbon dioxide is detected by the lime water. Now the symbol equation will be CuCO3 in solid state gives CuO in solid state plus CO2 in gaseous state. Therefore, the balanced equation for the heating of copper carbonate is CuCO3 in solid state gives CuO in solid state plus CO2 in gaseous state. Let us now have a look at formation of ammonium chloride. Using a glass tube, 3 or 4 drops of concentrated hydrochloric acid are added in a test tube. The test tube is stoppered and left aside for a few minutes. Using a clean glass tube, the same process is repeated using concentrated ammonia solution. Both stoppers are removed and the mouth of the test tubes are brought together. Thick white fumes are produced at the mouth of the test tubes. The white fumes are of fine solid ammonium chloride. The balanced equation for the formation of ammonium chloride is HCl in gaseous state plus NH3 in gaseous state gives NH4Cl in solid state. Balancing equations involving polyatomic ions. Many reactions involve chemicals whose formulae include polyatomic ions, which are sometimes included in brackets like Al2SO4 whole thrice. if such ions do not change during a reaction, which means they appear as the same polyatomic ion on both sides of the equation, they can be treated as one unit for the balancing purpose. This means there is no need to count the individual atoms of the polyatomic ions on two sides of the equation. 2CN in aqueous state reacts with H2SO4 in aqueous state to give K2SO4 in aqueous state plus 2HCN in gaseous state. Let us solve an example. Bubbling hydrogen sulfide gas through an aqueous solution of copper nitrate gives a black-colored precipitate of copper sulfide and an aqueous solution of nitric acid. Write chemical equation of the given statement and balance it. Solution: CuNO3 whole twice in aqueous state reacts with H2S in gaseous state to give a black-colored CuS in solid state plus HNO3 in aqueous state. Count the number of polyatomic ions as units on both sides of the equation. We now balance NO3 units by putting 2 before HNO3 and make the equation completely balanced. CuNO3 whole twice in aqueous state reacts with H2S in gaseous state to give CuS in solid state plus 2HNO3 in aqueous state. So, we should store in memory, for balancing purpose, polyatomic ions which do not change during a reaction can be treated as units. Let us revise. Chemical equation is a shorthand way of writing what happens in a chemical reaction. Chemical equations can be of two types: word equations and symbol equations. Chemical equations can be balanced or unbalanced.